Okay, here's the second in this series. We're still working on just the essential things we need. So we just put in the USB. We've got the 3.3 volts. We haven't actually connected it to anything yet. So let's go ahead and let's wire in some of that stuff. So we need the 3.3 volts connected into power, the microprocessor here. So these micros actually don't run at 3.3 internally. They run at 1.1. So, but it's got its own regulator to create that. So we just need to put the 3.3 into the right spots. So let me make a copy of the 3.3 volt tag here. Command D to, oops. There we go. Command D, and this is going to connect into this IO VDD line here that's on pin 1. Now I'm going to put this really high because there's a whole bunch of things that connect to this here. So we'll run that. So let me just do that. Now the other thing that the standard RP2040 layout in the KiCad is this just isn't pin 1. It's a whole bunch of pins. You only see it as pin 1. When we go to the layout side, you'll see that it's connected to, I think, 4 or 5 separate pins there. We could ignore that on the schematic side. It takes care of that for us. We also need to connect this to the pin 48 and pin 44. So let me just wire those in while I'm at it here. So I'll just come up a little bit. And so we've got these two are now connected. Now the other one that we need to connect is this ADC AVDDD in, and the odd thing about that is this is the power supply for the A to D converter, and we're better off if it doesn't have very much noise on it. So what we can do is we can add a simple RC filter on that, and that'll help us keep everything smoother. So what we want is we want a capacitor to ground and a resistor to feed it. So, well, a cap wise, the 10 microfarad will be fine. So I'm just going to reach over here and grab this 10 mic cap. And I'm just going to set that right there. And I'm going to, the bottom side, that'll go to ground. And I need a resistor. Well, I've just added a bunch of resistors. So we can, let me just copy one of those. So I'm just going to go grab a resistor. And I'm going to stick that on here too. And let me move this down just a little bit. Okay. And, well, the capacitor needs a ground on the bottom. Let me just grab one of those. And then I need let's wire this together. So, and we need to change that value too. Then this has to connect to that. So we can just grab this and connect it to there. Okay, but we don't want 5.1K. What I want is 100 ohms. So I'll just put the cursor on there, hit the E key, and we'll just change this to 100. And say OK. So now it's 100 ohms. Okay, so there's our power. And while we're at it, I'm going to throw another capacitor that goes between power and ground, and I want it, right near the processor itself. I've got the other one that's up here that's between power and ground by the regulator. I want to put another one by the processor chip. So I'm going to just copy this guy, Command D, and I'm going to put it, we're just going to put it over here. And I'm going to add a trace between there. So that's the 3.3, and I just want to connect the other side of this to ground. So let me move this ground down 1. Okay. And then let me add traces to this. Okay. So, with those parts already having the footprints assigned before I copied them, they are still just fine. Now the output of, you notice this one pin that says VREG in. The 3.3 volt goes in here. There's a regulator on the RP2040 chip itself, so it gets us down to 1.1 volt. So what I need to do is feed that over to the output of this to VDD. Now, this VDD pin also connects to a whole bunch of places. It only listed as one pin. It's at least two. I don't remember exactly how many. So these two need to connect together. But we also want a filter cap on this. So let me just grab another cap. And a 10 mic is probably what we want there. And I'm going to put it over here. I do want a ground, so let me grab another ground pin. Let me just connect that up. Let me go up, over, and down. And that'll connect to this one too. Okay, so this is our 1.1 volt line. I don't think we need it anywhere else, so I'm not going to bother putting a tag on it like I frequently do. Okay, so the next thing we need a crystal. Again, I'm trying to add the stuff that all the designs will need, all the basic designs. You may have something really fancy, but I need a crystal between X in and X out. So let me grab that. Another part. Crystal. It's a 4. The one I've got. Again, we're back to using parts that I have in stock. Okay, so I want the ground on pins 2 and 4, and I want the small version of it so it doesn't take up a lot of space on the schematic. Footprint. Mine is a Seiko Epson. What's the size of mine? My crystal is Seiko Epson FA238 3.2 by 2.5. Seiko Epson 328. Okay, that looks good. So footprints assigned. So here's my crystal. And the pins 1 and 3 are actually where it goes. So let me just rotate. Let's see, how do we want to do this? Let me just do this. I'm going to put it in line with the X outside there. I'm going to get rid of that label here in a second here, but we'll just go ahead and connect this. Now, on my designs, I'm a little different than what they frequently require with a resistance in series and a resistance in parallel with it. I've been leaving those blank and haven't had much trouble. I need they say that you want a 15 picofarad, so let me just grab a cap. And we may need to move some things around here. And they say it's supposed to be 15 picofarad, so let me just edit this one. And let me duplicate it, now that it's got the right value. Okay, so I'm going to get in the way of these two pins here, so I need to do something about that yet. Let me put the cursor on the crystal and hit E. The value is actually, it's a 12 megahertz. So that looks a little better. The labels are pretty far away though, so let me move some stuff around here. Let's move this to just enough space to clear things. This 12 megahertz can move. We're going to move it over here for the moment. And Y1, let me see if I can make it work there. Okay, so let me move this guy. And let me add some traces just to make sure everything fits. And I want to come over a little farther than I need to. And I'm going to probably move that cap up. Oops, won't let me do it that way. Let me go up it this way. Okay, let me try this again. So if I do a trace from there to there, there, Okay, that'll work. And then this one goes to there, but it also goes to that. I don't have those at the same altitude. Let me move this one down a notch, or move this one up a notch. Okay, and I'm going to move this label because I don't like where it's at. Let's move this over to here. And I'm going to move this label down here. The 15 picos, let me move those around a little bit. Just trying to make things look nice as we go. Okay, now these two pins connect to ground, so I need a ground. Let me grab one, zoom out, there's one. So now I can put my traces in for the grounds. Okay. The pins 2 and 4 are actually not connected, so I need to connect those with the X's to tell the system that we're not using those. Okay, so now we've got a crystal. Here's the ground pin for the microprocessor. Let's connect that. So Command D, duplicate the ground, put that there. Okay, so that's good. I've got the memory chip yet, and these two guys in the test and run lines. So the test enable is actually just gets grounded. So I can just duplicate that again and then just run the trace. The run line needs to connect to a 10K resistor to the plus 3.3. So I just need a resistor. And they're all the same package, which is what I'm interested in. So let me duplicate the resistor that's there. And let me just set that there. Hit the escape key. And let me type an E to get back to this. And I want 10K. And I want it to go to 3.3. Well, there's a whole bunch of 3.3s. Let me just come up here, duplicate that, put it there. Let's run these traces. Okay, so there's the run, there's that. I've got the memory yet, and I've got this SW clock and SWD. When you're developing stuff with this particular processor, it's really convenient when you can just hold that boot button down and bring it up in USB as a thumb drive and copy it to it. It's getting started, that works great. If you do very much development on them, it's kind of a pain because you have to kind of like unplug it and plug it back in all the time. So you really want to program it through the SW clock and SWD, or at least have that ability in the future. So I'm going to put a connector on here. But at the moment, what I really need is just a couple of labels on here so I can put it on the connector. So let me just swipe these two, right-click, pin helpers, global labels. Okay, so those are my labels for SW clock and SWD. And I'm going to put in a 3-pin connector. And I'm just going to put it up here where I can keep it out of the way of everything. And I'm going to use those symbols. So let me get a connector generic here. Crystal, well, let's see, connector. Those are special connectors. I don't want that. I want connector generic. There we go. And I'm going to use a 3-pin connector. Oh, let me escape on that again. Let me go back and do that one more time. 3-pin footprints. I can assign it here and then be done with it. Let's see, connector, Molex, fix the wire, solder. Let's see, pin socket. That sounds good. 2.54 vertical. 1x3. Awesome. Yeah, that looks right. So here's my connector for those symbols. And I'm just going to put it out of the way over here. And I want it to match some of my other boards. On pin 1, I have SW clock. So let me just duplicate that symbol and just put it there. On pin 3, I've got the SWD line. So let me just get that one, make a copy of it, and just move that over there. And then the pin 2 needs to be grounded. So let me put a ground over there. So let me just Command D on a ground, put that somewhere nearby, and let's zoom in here a little bit so you can see it. So we're going to put a trace there, and a trace there. Okay. So now the only thing we need this to actually function would be is to add the memory chip. So let's go back and add another part. And I want the W25. Oh, it's already there. And I want the, which one? I want the JVSS. JVSS. That is the one selected. Again, this is, I'm selecting this one because that is what I've got. Now I'm going to put that right there. And I'm going to come back here. Let me zoom back in again. Let me just hit the escape key so it doesn't try to insert a second one. I'm going to swipe all these parts, right click, pin helpers, global labels. Okay. And then I'm going to, I need all of these over there. In fact, if I can need this down just a little bit, because I know I need a button in here too. So let me go down just a little bit with this. So let me zoom in. Let's take care of the ones we need first. The data 0 line, that's D0 is right there. The data 1 line, that goes right below it. The data 2 line. And the data 3 line. There's the clock. Okay, so those lines are there. We do need a ground. Let me just grab that while I'm at it. And I need a 3 volt. We do need 3.3 volts for this thing. Let me go grab one of those. Oh, here's one. Duplicate. Okay, now the chip select, we need it wired just kind of a little bit differently. This all does connect, so I need, there's my chip select signal here. But we get a couple of extra things in here. Let me just wire some of this stuff in here. These guys just connect straight in. And even though this connects, oops, I need a couple other things on there. I need a resistor, a pull-up resistor, 10K to plus 3.3. Well, while I'm wiring the wire, let me get that one in there. And let me get this one in here. Okay, so I need a 10K pull-up to 3.3. We just stuck a 10K in there. There it is. So let me duplicate this part. There's 10K already for us. And I want that just there. And we'll just wire that one side in. Now the other side, I want a 1K resistor to a button to ground. So I need a 1K next to that. I haven't actually put a 1K resistor in there. Let me duplicate that. And I edit it. Let's make it a 1K. Let me draw some lines. Now I need a button. Okay, so I need a button. So where is switch? I got all these switches. Single pull, single throw. That is exactly what I want. Okay, single pull, single throw switch. And it doesn't have a button listed there. Okay, so I'll have to assign that the other way. Not tragic. So here's the switch. That's our boot button. And then the other side of the switch has to go to ground. So let me hit the escape key, get out of that. Duplicate the ground symbol, put that there. And then draw that. Okay. Oh, we need this one too. So now everything's wired in. So this should be everything that we need for the board to function. We can't actually talk to it yet. I mean, we can talk to it through USB, but there's no lights, there's no doing anything with it yet. So, but that'll be the next video. So right now what I want to do is, let me go look at the footprint stuff. And we've got one that's not assigned. That's our switch here. And if I go back up here, there's a button, and I've got a list somewhere that tells me which button I've got in stock. That's always the thing I need to do. Button, switch, SMD, SW, SPS. Okay, there's the dips. Push. SPST, CK, RS282. CK, that, there it is. So that's the one. If I double click on that, it fills it in. Say OK. So now it's got all the devices have everything saved. Save your work. And as I said, this is everything it needs to run. So I could plug it in, hold the boot button, plug it in, and it would come up as a thumb drive. I could program it. I just don't have any lights or anything else. So let's stop here. And the rest of it is the things that we want to make for changes.